This unit will introduce you to manufacturing systems. An apparel production system is an integration of materials handling, production processes, personnel and equipment that directs workflow and generates finished products. The types of production systems commonly used in mass-produced apparel are make-through production system, progressive bundle unit system, unit production system and modular production systems. This unit comprises of 4 modules and a final review section that invites you to reflect on what you have learned. By the end of this unit, students will be able to understand manufacturing systems, identify a suitable system to suit business needs. We will begin to learning about the make-through system. Each system requires an appropriate management philosophy, materials handling method, floor layout and employee training. Firms may combine or adapt these systems to meet their specific production needs. Firms may also use only one system, a combination of systems of one production line or different systems for different production lines in the same plant. The second module will explain about the progressive bundle unit system. The progressive bundle system, that is also known as PBS, gets its name from the bundles of garment parts that are moved sequentially from operation to operation. The system, often referred as the traditional production system, it has been widely used by apparel manufacturers for several decades and is still in today. The Asian Apparel and Textile Machinery AAMA Technical Advisory Committee in 1993 reported that 80% of apparel manufacturers use the bundle system. They also predicted that the use of bundle systems would decrease as firms seek more flexibility in their production systems. Bundles consist of garment parts needed to complete a specific operation or garment component. For example, an operation bundle for pocket setting might include shirt front and pocket that are to be attached. Bundle sizes may range from 2 to 100 parts. Some firms operate with a standard bundle size, while other firms vary bundle sizes according to cutting orders, fabric setting, size of the pieces in the bundle and the operation that is to be completed. Some firms use a dozen or multiple of a dozen because their sales are in dozens. Bundles are assembled in cutting room where cut parts are mashed up with corresponding parts and bundle tickets. Bundles of cut parts are transported to the sewing room and given to operator scheduled to complete the operation. One operator is expected to perform the same bundle on all the pieces in the bundle, retie the bundle, process the coupon and set up aside until it is picked up and moved to the next operation. A progressive bundle system may require a high volume of work to process because of the number of units in the bundle and large buffer of backups that is needed to ensure a continuous workflow for all operators. The progressive bundle system may be used with a skill center or line layout depending on the order that bundle are advanced through production. Each style may have different processing requirements and thus different routing. Routing identifies the basic operations, sequence of production and skill center where those operations are to be performed. Some operations are common to many styles and at those operations work awaited to be processed may build up. The success of a bundle system may depend on how the system is set up and used in a plant. This system may allow better utilization of specialized machines as output from one specialized purpose. Automated machine may able to supply several operators for the next operation. The progressive bundle system is driven by cost efficiency for individual operations. Operators perform the same operation on a continuing basis, which allows them to increase their speed and productivity. Operators who are compensated by piece rates become extremely efficient at one operation and many not be willing to learn a new operation because it reduces their efficiency and earnings. Individual operators that work in a progressive bundle system are independent of other operations and the final product. Slow processing, absenteeism and equipment failure may also cause major bottlenecks within the system. Large quantity of work in process are often characteristics of this type of production system. This may lead to longer throughput time, poor quality concealed by bundles, large inventory, extra handling and difficulty in controlling inventory. The third module will explain about the unit production system. A unit production system, that is also known as UPS, is a type of line layout that uses a overhead transporter system to move garment components from one workstation to another for assembly. All parts for a single garment are advanced through the production line together by means of a hanging carrier that travels along the overhead conveyor. An overhead rail system consists of the main conveyor and accumulating rails for each workstation. The overhead conveyor operates much like a railroad track. Carriers are moved along the main conveyor and switched to an accumulating rail at the workstation, where an operation is to be performed. At the completion of an operation, the operator presses a button and the carrier moves on to the next operation. Most unit production systems are linked to a computer control center that routes and tracks production and provide up to the minute data for management decisions. The automatic control of workflow sorts work, balances the line and reduces claim of favoritism in bundle distribution. Electronic data collection provides payroll and inventory data, immediately tracking the styles, costing and performance data for prompt decisions. Processing begins at a staging area in the sewing room. Cut parts for one unit of a single style are grouped and loaded directly from the staging area to a hanging carrier. Loading is carefully planned so minimal handling is required to deliver garment parts in precisely the order and manner that they will be sewn. When possible, operations are completed without removing the parts from the carrier. Varied sizes and types of hanging carriers are available for different types of the products. Automated materials handling replaces the traditional system. This of the bundling, tying and untying and manually moving garment parts. Unit production systems eliminate most of the lifting and turning needed to handle bundles and garment parts. The need for bundle tickets and processing operator coupons is also eliminated when an integrated computer system monitors the work of each operator. Individual barcode or electronic devices are embedded in the carriers and read by a barcode scanner at each workstation and control points. Any data needed for sorting and processing, such as style number, color set and lot, can be included. Integrated systems have online terminals located at each workstation to collect data on each operation. Each operator may advance completed units, reroute units that need repair or processing to a different station and check their efficiency and earnings. An operator may signal for more inventory or call for a supervisor if assistance is needed. The terminals at each station enables the central control center to track each unit at any given moment and provide management with data to make immediate decisions on routing and scheduling. Operators of the UPS control center can determine sequences of orders and colors to keep operators supplied with work and to minimize change in equipment, operations and thread colors. A unit production system can control multiple routes and simultaneous production of multiple styles without restructuring production lines. The control center may perform routing and automatic balancing of workflow, which reduces bottlenecks and work stoppage. Each operator as well as the control center is able to monitor individual work history. Data can be collected on amount of the time an operator works, time spent on each individual unit and number of units completed, the operator who worked at each unit and the piece rate earned for each unit. The system will calculate earning per hour, per day and the efficiency rate of each operator. Benefits of a unit production system depends on how a system is used and the effectiveness of management. Throughput time in the sewing room can be drastically reduced when compared to the progressive bundle system because work in progress level is reduced. Operator productivity increases. Direct labor costs are reduced because of pre-positioned parts in carriers and elimination of bundle processing. Indirect labor cost may be reduced by elimination of bundle handling and requiring few supervisors. Quality is improved because of accumulation of all operators and immediate visibility of problems that are no longer concealed in bundle for extended periods of time. The central control systems make it possible to immediately track a quality problem to the operator that completed the operation. Other benefits that are realized are improved attendance, employee turnover and reduced space utilization. A unit production system can be expensive to buy and install, requires specialized training for system and prevention of downtime, can experience frequent downtimes, has low work in progress which can make the UPS specifically vulnerable. The final module will explain about the modular production system. A modular production system is a content manageable work unit that includes an empowered work team, equipment and work to be executed. Modules frequently operate as mini factories with teams responsible for group goals and self-management. The number of teams in a plant varies with the size and needs of a firm. Teams can have a niche function as long as there are orders of that type of product. But the success of this type of operation is in the flexibility of being able to produce a wide variety of products in small quantity. Many different names are currently used to identify modular apparel production systems, including modular manufacturing, cellular manufacturing units, compact work teams, flexible work groups, self-directed work teams and Toyota sewing system, that is also known as TSS. The basic premise is similar among these systems, although the organization and implementation may vary. The number of employees on a team, usually 4 to 15, vary with the product mix. A general rule of thumb is to determine the average number of operations required for a style being produced and divided this by 3. Team members are cross-trained and interchangeable among tasks within the group. Incentive compensation is based on group pay and bonuses for meeting team goals for output and quality. Individual incentive compensation is not appropriate for team-based production. Teams may be used to perform all the operations or a certain portion of the assembly operations, depending on the organization of the module and processes required. Before a firm can establish a modular production system, it must prioritize its goal and make decisions that reflect the needs for the firm. With a team-based system, operators are given the responsibility for operating their module to meet goals for throughput and quality. The team is responsible for maintaining a smooth workflow, meeting production goals, maintaining a specified quality level, and handling motivational support for the team. Team members develop an interdependency to improve the process of accomplish their goals. Interdependency is the relationship among team members that utilizes everyone's strength for the betterment of the team. A modular production system operates as a pull system with demand of work coming from next operator in the line to process the garment. Wastage is normal and workflow is continuous and does not wait ahead of each operation. This increases the potentials for flexibility of styles and quantities of products that can be produced. Workspaces are two kinds: stand up or sit down units and work zones. Team usually operates of sit up or sit down units. A module may be divided into several work zones, depends on sequence of operations and the time required for each operation. A work zone consists of a group of sequential operations. Operators are trained to perform the operations in their work zone and adjacent operations in adjoining work zones, so they can move freely from one operation to another as the garment processes. Workflow within a module may be with a single piece handoff, Kanban or bump back system. We will look at each of this in detail. If a single piece handoff is used, machines are arranged in a very tight configuration. As soon as the operation is completed, the part is handled to the next operator for the processing. Operations need to be well balanced as they are usually only one garment components between each operation. A Kanban uses a designated workspace between the operations to balance supply with demand. The designated space will hold a limited number of complete components, 2 or 3, in a queue for a next operation. If the designated space is full, there is no need to produce more until it is needed or the space empties. This limit built up the product ahead of next operation. When the space is full, of operator can assist with another operation that may be slow. The bump back or Toyota sewing system, also known as TSS approach, was developed by the Toyota Sewing Product Management System and is probably the most widely used type of the team-based manufacturing. It is a stand-up module with flexible work zones and cross-trained operators. Operators may be cross-trained on up to 4 different successive operations. This enables operator to shift from operation to operation until the next operator is ready to begin work on the garment. The operator needing work steps to the beginning of the zone and takes over the processing at whatever point it is in the production process. The operator who has been relieved of the garment will then move back to the beginning of the work zone and take over work on another garment. This approach enables continuous work on a garment and allows each operator to perform several different operations. This arrangement frequently uses a 4:1 ratio of machine to operators. The advantage of a modular production capacity are high flexibility, fast throughput times, low wastage, reduce absenteeism, reduce repetitive motion element, increase employee ownership of the product process, empowered employee and improved quality. The disadvantage of a modular production system is a high capital investment in equipment, high investment in initial training and high cost incurred in continued training. Some firms may use the progressive bundle system for producing small parts combined with modular production system for garment assembly. This reduces the investment in specialized equipment and the required team size. Some industry consultants believe that a modular production system combines with a unit production system provides the most flexible, fastest throughput and most consistent quality. This would be particularly useful for large items such as cover all or heavy coats. The UPS would move the garment instead of the operators. Each manufacturer needs to determine what is best for its production line and production requirements. To summarize, in this unit, you have learned about the make-through system, progressive bundle system, unit production system and the modular production system. Understanding the various kind of systems will help you identify a suitable system for your business requirements. Thank you very much.